I will try to stump you now. My code's a puzzle, but you don't frown. You got answers for every line loop. Oh, clever camel, master of the code. You solve the mysteries, a heavyweight load. BFDs and PLCs, you know it all.
Welcome back to another video. Today's video is another answer your question type video. This question comes from Samela. He asks, can I use the M700 drive with a bus coupler without the MCI210 module? Then he gives an example of a couple bus I/O couplers up here. Hopefully this video answers your questions and also gives you some insight on how the RTMoE network works. Alright, before I get too far into the video, there's a few things I need to mention about this bus coupler. First off, it has two protocols that it uses. The first one is Modbus TCP. We're not going to do anything with Modbus TCP because what we're trying to do today is we're going to use the real-time motion over Ethernet protocol, RTMoE, to let the drive talk to the bus coupler. The reason we're using this protocol is because Modbus TCP requires that there is a client asking the server questions. In other words, there needs to be a master device somewhere that goes out to the bus coupler and sends it data and also requests data. We don't have that option if we only have a M700 drive, right? Now we do have that option if we have an MCI210 module. So an MCI210 module could talk to the bus coupler using Modbus TCP, and that is something I can teach you how to do in the future if that's something you would like to do. The nice thing about knowing how to do Modbus TCP is that it also allows you to use other brands of bus couplers, like those from Phoenix. Regardless, today we're talking about real-time motion over Ethernet. The nice thing about this protocol is no master devices need to be in the network. Basically what happens is each drive will just send the data to the other drives because you told it what data that it needs to constantly send. The same thing is true with the bus coupler we're going to use today. We're just going to set it up so that it constantly sends all the data that it's receiving from the digital inputs to the drive automatically. In fact, this is kind of cool because we can set up the bus coupler to send it to all of our drives. So let's say we have 5 drives and we want all 5 drives to use that same bus coupler, and some of the digital I/Os, some of the drives will use, and others, the other drives will use. This is kind of slick. As far as writing to the bus coupler, you can only have one drive write to the bus coupler. Without wasting any more of your time, let's get started. So the first thing we're going to do is we're going to open up Machine Control Studio, and we're going to create a project by just scanning the way I have my networks set up. And to do that, we're going to click this new project from Network Scan. Now you could totally do this by going to New Project, but there's no reason for it for this video. So you can see it's found my drive and it's found the bus coupler. You can change the IP address if you'd like. You can also wink it. So maybe you have more than one bus coupler, which is possible. You could have multiple bus couplers, and you need to know which one is which. So these little wink buttons are pretty handy. But my IP addresses for my bus couplers are already set up, so I'm just going to go on to the next step. Now the next thing you'll see here is the project was set up for me, and it found the bus coupler and put it up here. It put my drive here, and it also put the MCI module in slot 3, which it is in slot 3. You'll also notice that this drive has a application here and an application here. Basically what this is 2 different PLCs. This is a PLC and this is a PLC. There's one built into the drive and there's one built into the MCI module. Remember, the question was, how do we get the I/O module to basically talk to a drive without the MCI module? Well, I'm going to start showing you how to do it with an MCI module. So you're going to actually learn both today. We're going to start with this because I think it's easier, so you can see how it kind of works. And then I'll show you how to do it with here. Regardless, the steps are basically the same, except for the last little bit. So the first thing we're going to do is we're going to click up here in this little green circly arrow thing, which sets up the real-time motion over Ethernet. That's that protocol we're going to be using today. And you're going to see there's these little tabs of things. Just a couple notes. This is just some basic information. There's some web links and help or whatever. And it also kind of gives you a picture of what it looks like to set up a bus coupler with multiple drives. Let me just show you. So here in this section, you can write some notes, whatever. I don't ever use it. Here's the wizard. Again, I never use it. All I really care about are these three last tabs. So the devices here show you all the devices that are inside your project. Now, we can see that here's my bus coupler, right? We can see here's my drives PLC, right? And this is the MCI210 is right here. Oops, right here. Okay, now it's allowing me to change the IP address, I suppose, of the MCI module, or set it. It's already set to what I want, so I'm just going to leave it be, okay? And I don't want to create links to this drive here at all. We're going to turn that off. So here's my two devices that I care about. I'm going to go to mapping. And you're going to see that there's these two little antenna things here. And what we're going to do is we're going to basically get some arrows pointed between these two. And the first one, I'm going to get an arrow from the bus coupler down pointing towards the MCI module. In other words, I want data coming from the bus coupler to the MCI module. And to do that, you click here and you drag down. A little window pops open and says create generic, and then you say yes. Okay, right, pretty easy. So now all the data from this bus coupler is going to show up into the MCI module. Now I also want the MCI module to be able to write data to the bus coupler, so I'm going to click here and drag straight up. Perfect. Now I have two arrows. Now these two arrows are the links that we're playing with. That's why it's called the Advanced Link Editor. So when I click on this arrow here, see how it's blue? The data down here is related to this arrow. Okay, so we can see that there are a few things that's going to be sent. There's going to be a control word. Here, let me move this up. There's going to be a control word and 16 digital outputs. On the other one, this is data coming from the bus coupler to the MCI module. And if we expand this, we can see that there's going to be a status word, and there's going to be, well, 16 total inputs. And so there's nothing really here for us to play with that much. You can set up the timeouts and change the sample rate. You know, remember originally it set it to 10 milliseconds. I could make it 20 milliseconds. I could make it less. Just note that the faster you make it, the more bandwidth you're taking up on your network. Remember, this is associated with the link I'm clicking on. So if I click here, see it's a different link ID, right? Perfect. So the last thing you do is you come down here to download, and it's going to download this information to this bus coupler. And you saw it go online for a little bit with the bus coupler, and then you saw it go online with the MCI210 module. All right. So you can see they both downloaded, and now that they're downloaded, if we come back to mapping, one thing I'd like to mention is there's this online monitoring thing you can turn on here under mapping. And if you see both of these turn green, then that means both MCI module and the drive have been set up correctly. Data's actually flowing back and forth and everything's hunky-dory. You might also see it show a couple different colors. For example, it might be waiting for data to start showing up, right? So it might be saying it's transferring data, but it's not receiving any. You also see that this bus coupler here is kind of tripped. What happened here is it downloaded to the bus coupler first, and then it lost the communication, and so it tripped on the cyclic watch out. So we're just going to clear that for now. It'll happen anytime you break the cable or whatever, right? You'll get a fault condition to happen. Yeah. No big deal. So that's basically all there is to set up these links. Now let's see how we actually use these links within the MCI210 module. Well, one thing I should note is that it created this thing here automatically. See where it says auto code, and it gave it this name IO210BC. Now you'll notice that this is the exact same name as this bus coupler. If we wanted to rename this bus coupler to something else, we could, and this would have also automatically renamed. So just for kicks and giggles, I'm going to rename this. Actually, I'm going to also rename this and this. Let me show you why before I rename it. I like to rename my slices just because, GT12DF doesn't mean anything to me. That's just the part number of the IO slice, right? So let's first come into freewheeling task. Okay, and I have it set up as structure text as my default startup here. It could be ladder logic, it could be whatever, but in freewheeling here, I am going to read data out of this IO module, right? And so what I'm going to do is I'm going to say my inputs, and then I'm going to use whatever this name here is. And you can see that there's a control word, a status word, and then these two things. Now I know that the blue one is my inputs, right? But I wouldn't know from the part number. And so normally what you do is you click this, and then another period, and then all channels. And then this would whoops. Yep. And then this would take all of the bits and move it over into my inputs. I could also do it like this, input 1 is equal to channel 0, right? And so you can see that this one's a Boolean, this one's an integer, right? And they both do the same thing, except this one's reading only one digital input, and this is reading all of the digital inputs, right? So either way works, which is nice. But the issue here is this is kind of confusing. So I'm going to rename this to make more sense. So I'm going to hit properties. I want to leave GT there and then just type inputs. Or you could say slice 1 or whatever, but I'm going to say inputs because I only have one input card and one output card, right? Okay. Now you'll notice that my code is already upset because there's nothing called GT12DF anymore, right? And if I come in here, right, delete that, there, you'll see it's GT inputs, right? So that's nice. That's more readable, I think. And then also the bus coupler, I guess you can keep the name, but the same thing's true. You can come up here and rename it. So I don't care. We'll just leave it there. But if you have more bus couplers, like one for one end of the machine and one on the other side of the machine, it would be good to have different names because you might have a north side and a south side IO block, right? Before we go on to the digital outputs, I want to talk about the status word a little bit. So as you know, we got the status word. It came with the inputs, right? And it has some good pieces of information. Primarily, I would look at it from the point of knowing when the digital inputs are ready to actually be used, right? You don't want to start your machine until you know that the digital inputs are actually talking to you. So here is the bits that come across that are important, and you'll see that when it shows up as a value of 5, the system is operational. So I'll leave this here just for a second so you can get a screenshot or notes or whatever, but it is in the bus couplers user manual. All right, I'm not going to be using that today. So on the digital outputs, how do we use them? Well, do the bus coupler just like we've been doing. type out the bus coupler's name, go to digital outputs, hit a little period there, and you'll see that we have all channels, just like we had with the inputs, or we can write to each digital output individually. Now, there is one thing I need to mention that caught me the first time I was dealing with this. Some of the digital outputs have this mask parameter thing. Not all of them do, but some of them do. I guess the point here is to prevent you from writing to certain digital outputs if you don't want this drive to be able to control them. The key thing here is that none of these here that you write to will work unless the mask is true, right? So it's a bit-packed word. What we need to do is pull up a calculator, and we know that this particular digital output has 16. What we're going to do in this calculator under programming mode is find the correct value to put in here if we want to unlock all of them. So I go here and hit binary and just click this 16 times. As you can see, that comes up with a value of 65,535. We need to set this equal to 65,535. So now we can actually write to any of our digital outputs we want. So I'm just going to write to a single digital output, and I'm going to make that channel 0. And I'm going to make that just a test value. So there's our program. Nothing too complicated. And all I have to do now is download the code. Go online. Now the problem here is that I downloaded the code, and I can see that my I/O block is now not happy. See the 2 red lights? So there was quite a bit of configuration change going on, and so it's not happy. So what we're going to do here is I'm going to come over here and clear the trip. Now you can see from the video down there that the trip is cleared. So that will happen if you've changed configuration. So we did change stuff. But once you've got your configuration set the way you want, that won't happen anymore. You could have also power cycled the I/O module. Okay, so let's go and play with this a little bit. So right here, we can see I have no inputs turned on, right? But now I'm going to turn on an input. See? See how that works? Now I want to actually turn on an output. So I'm going to double click here because I want it to be true, right? Then what I'm going to do is I'm going to come up here to build, or somewhere here. There should be a write. There it is. Write my values. So I wrote a value of true to the 1 bit. And we can see from the video in the bottom right corner here that it did turn off. Did turn on. I'm just going to use my keyboard to turn it on and off. So you can see that's working. So it was pretty simple to get this to work. Now the question is how are we going to get this to work without the MCI module? Well, it's actually pretty easy. So I'm going to go offline and get some baseline of what we're going to look at. Remember in the advanced link editor, I told you that these links had to do with the way the network data is being transferred back and forth. And you'll see, well, let's do the first one, is the data coming from the bus coupler to the MCI module, right? So we're going to go to a menu called menu S in the Connect software, parameter 20 and 21, and we will see that this data is just showing up automatically in these parameters. And really what's going on here in this little piece of code that was written is it's just going out and reading this data in these 2 parameters, right? So this is S20 and this one is actually S21. Don't edit this code, but really all that's happening is the module is actually just sending the data to some parameters inside the MCI module, and the MCI module is just reading those using this little automated code that it created. Okay, let's go look at that. So I'm clicking on the MCI module, and I'm going to, where did I say? S, right? And you'll see here's S20. And there's the 5. So we got the status word. It's right there. It's ready. Remember I told you in the manual that the status word is a 5. So we can just read this data right here. And right here will be the actual value. So as you can see right here, I'm turning on the bit, right? If I turn on this bit, right? So you can see that it's just a bit packed value here that we just have to get our data from. So that's pretty easy. The next thing, how is the reads working? Well, it's working exactly the same. And if we go back to Machine Control Studio, this link editor here, we will see that it's the same thing, just a different menu. So this is menu S, the data coming from the bus coupler to the MCI module. And this one is coming from menu R and going to the same kind of things. In fact, we should be able to go online here, stop our code, right? I'm just going to stop this code so it can't actually run, go offline, and we will still be able to change data on the bus coupler. So if I come over here to the bus coupler, menu R, okay, here are our two menus, right? I didn't mention this earlier, but there is a config thing. Basically, all you can do is reset there by setting this to 1 and then turning it back off. But this is our mask and also our digital inputs. And so what we're going to do here is I'm just going to slowly increment this. Well, actually, I'm going to do it pretty quickly. And you're going to see all the digital inputs race upwards. See? So technically, we don't need the MCI module at all. We just need to be able to get this 2 pieces of data to not be sent to the MCI module. What we need it to do when we set it up, we need this data to be sent to menu 20 somehow. And as you can see, you don't technically need the MCI module if all that's really happening is the data is showing up in the parameters. So let's do the same project. We'll do it quicker this time. Okay. All right. So now we're going to start from scratch, but my system's a little different. I have removed the MCI module, and so it's just a drive and this I/O block. So we're going to go to File. I'm going to say New Project from Scan Network. And you're going to see that it found the bus coupler and drive just like before. Now if we look over on the left side, we can see the bus coupler and the drive, but there's no MCI module. So we're going to prove here that you can actually talk just between 2 devices that are not master devices, right? They are not client devices. So same thing, we're going to hit this cyclic link editor. We're going to skip to devices, make sure those are both checked, come to mapping, drag down. Remember I stated that you can have the bus coupler send to multiple drives. One easy way to do this is not to use an IP address. We're technically telling the bus coupler where to send this right here, and you'll see there's this link number 1 here. What I want to do is I'm going to set it to multicast. So this means that I get to select one of these multicast addresses, and the data will be sent to any device that's listening for this address on the network. And so multiple devices can actually read this I/O, which is cool, right? So I'm going to hit OK, and now I'm going to go the other way. And now on this one, I don't want to do multicast because I only want one master or device writing to the bus coupler, right? And so I'm going to leave this one as a specific IP address. So here's the link number, so that's important. So everything here is basically set up, right? So it all looks the same, nothing's different. We come down here and hit the download. Okay, so we see it downloaded to the bus coupler, but it didn't download to the drive. That's right, the drive itself doesn't know anything about these easy links. Actually, that's somewhat of a lie. The drive itself has easy links, but this is the advanced link editor, not the easy link editor. So what we got to do is kind of link the two together. And it's really easy as long as we know some key things. Remember, if I click these little link things, there's these link IDs, and I just need to know this information. So let's go set it up, okay? So I'm going to open up Connect, and what we're going to do is we're going to use menu 20 for the location where we're going to share the data between the bus coupler and our drive, okay? So I'm going to click on the Ethernet module that's built into this M700, and I'm going to come down to Easy Mode. That's right. And in this Easy Mode, you will see that there are 3 transmits and 3 receives. And we only need 1 transmit and 1 receive per bus coupler, right? I guess if you're only receiving data from the bus coupler, you technically only need a receive link and you don't need a transmit. Okay, so as you can see, I kind of got this already set up, but let's make sure I got it set up correctly. So I'm going to move my Connect software over here, and I'm going to move the Machine Control Studio software to this side so we can just look side by side to see what's going on. Okay. All right. So data from the bus coupler to the drive. Okay. It's link ID 1. So this would be stuff that the drive is receiving, right? Receive. See that 1? There's that 1. Very good. Then this, and then this here is 2 pieces of data. Let's go to the mappings. You can see there are 2 pieces of data here, right? So 2. And then if we come back here, we can see that it is a multicast, right? And so, which multicast is it? It's multicast 1. So we select multicast 1. Everything is set up correctly. Very good. And then we come over here and do the same thing for transmit. See, link ID number 2, link ID number 2. It is directly being written to this device, right? So we're using unicast, means we're just writing to one device, and there's its IP address, so that's good. We're writing to it every 10 milliseconds, and the parameter count, how many things are we sending it? Well, let's go to the mapping. We see that there are 2 words here, so we're sending it 2. Very good. And so that is basically it, other than this parameter right here and this parameter right here. So far, I haven't mentioned what they are. Well, I kind of have. They have nothing to do with this. They have everything to do with the drive. Let me explain. So, remember, we're receiving data, but we need some place to stick it. And what this is menu 20. It's menu 20, parameter 31. And this is menu 20, parameter 25. And as you can see, I'm already receiving data here because I already happen to have this going. But normally, after you put all this data in here, you would go up here and hit Save Parameters in Drive. And then at the top of this, see this reset? You would hit Reset. And this network message would count up to basically 200 a second. That's because this is at 10 milliseconds, and this one is also receiving at 10 milliseconds, okay? Now you can see that the data we're receiving has changed to 261, which basically means that the I/O module is mad. Now why is it mad? Well, it's because I reset this, and the I/O module saw the network trip. And it's like, what's the story? I'm not happy. It's not stable, blah, blah, blah. Remember, this is the receiving stuff. So I'm just going to label this as inputs or status, right? And I'm going to label this as inputs just to make things a little easier to understand. And up here, this is menu 20, parameter 21. So this parameter here is config. And this one right here is outputs. And so if I come up right here to config and I put a 1 here, it reset the I/O module. You can see in the top that it is now happy. Okay, and now we should be able to write to the outputs, right? So let's try that. So we're going to increment this. And as you can see, they are not changing. Well, why is that? Well, remember, there's this mask that we have to have applied, right? And the value we need in here is a negative 65,536. Now, if we increment it, you'll see that the lights come on. All right. So why is this? Well, let's bring over that calculator again. Okay. And if I look at this value, this negative 65,536, okay, that in hexadecimal, that's FFF0000. Or if we look at it as a binary, it's a whole bunch of ones followed by a whole bunch of zeros. Each one of these zeros represents one of the digital outputs. And each one of these ones represents the mask associated with one of the outputs. For example, this output and this mask work together. So if you want to control this digital output number 1, which is this bit, this mask must be on. And so that's where this magic number comes from. So there's 16 zeros and 16 ones, okay? So now we can easily increment this and see the digital outputs change, right? Very good. And we can also come down here and see the inputs change as I push the buttons. See? Everything seems to be working. So back here on Machine Control Studio, I'm going to show you how to actually read and write to menu 20 for those who don't know how to do this. So the syntax is right there. This represents menu 20 parameter 32. And right here, this is menu 20 parameter 22. So you can see right here, my inputs are reading menu 20 parameter 32. And then these two lines of code are just unbit packing this value. And the outputs work exactly the opposite. Now the little magic here is this negative 65,536. Remember, that's that offset that we need to allow us to write to the actual digital outputs. Otherwise, it'll ignore our request, right? So what I'm going to do is I'm going to go online here. All right, so I'm online and I start the little PLC code here. And you can see there is a negative 65,536 there, just like it shows here. And there is a value of 0 here on the inputs, just as it shows here. Now, if I push the buttons, you will see the light turned on the input. And you also see that input 1 came on here. Now, if I push input 2, look at that. Perfect. And if I push them both down at the same time, very good. And we can do the same thing with the output. All right. And as you can see, the output here is turned on, right? The value is changed a bit and output 1 is turned on. Very good. Let's go ahead and turn on output 2. As you can see, both outputs are on. So that's really how you go about doing this, okay? And if you have any more questions, let me know. Thank you so much for watching. If you found this video helpful, don't forget to subscribe so you don't miss out on further content. And remember, if there is a specific topic you would like me to cover, just let me know. I'm always open for suggestions.